Hi, Simeon Gabriel. Welcome to a tutorial or we teach data analytics and machine learning. Now, what we want to do today is we're talking about the NumPy library. Yeah, and at the end of this course, we'll be able to explain NumPy and its importance. We'll discuss the basics of NumPy, including its fundamental objects. Then we'll demonstrate how to create and print a NumPy array. We'll analyze and perform basic operations in NumPy. Then we'll see how we can utilize NumPy by shaping, manipulating its shapes and copying method. Then we'll go ahead to demonstrate how to execute linear algebraic functions. Then we may possibly build a basic program using NumPy. Now, what is NumPy? When we say NumPy, let's say the NumPy, what comes to your mind? Now, when we talk about NumPy, we mean numerical Python. Now, yeah, that's the meaning of NumPy, and NumPy is a library that helps us to actually do mathematical operations on the entire objects that we have. Now, what gave the rise of NumPy or the creation of NumPy is due to the limitations of a list. So now let me recap the features of or the properties of a list so that we can know and we can identify the limitations that give birth to the creation of the NumPy library. So before that, let me just give a header so that we can be able to monitor what we're doing here. So we'll just make this a header. So now, what are the properties of a list? Now, one, collection of values. Now let's create a list. This is a list. Let's say distance. These so these a list we want to create. So let's say distance. So let's say distance, probably 10, comma, 15, comma, then let's say 17, comma, let's say 26 or whatever. So now we've created a list, but mind you, we've not run it. Let's create another list called time. So we want to just identify first of all the properties of a list, just recapping on it. So let's say point 30, then comma, let's say 0.47, comma. Now this means 0 point. So if we put the point without the zero, it's still the same thing. So let's say 0.55, comma. So let's say 1.20. Now we succeeded in creating two lists, giving them different variable names, so we can run it. So successfully ran, didn't throw us an error. So one of the properties of a list is collection of values. Now what next? What is the next property of a list? Is it takes multiple data types. Okay, it contains heterogeneous data types. So what we mean by heterogeneous data type is contains mixed data type, like it can contain integer, string, float, boolean, as many data types that you can remember. So let's see. So that is it. So you can see it. Now, what can we do on a list? We can add, we can remove, we can update, but we cannot perform a mathematical operation on these two entire lists. Like we cannot do the addition or the subtraction or the multiplication or division or exponential on the entire list. So we have run this, so we can actually prove that. So let me give this speed. Let's say speed is equals to, now let's do a division on these two stuff. So let me copy this and paste it here. So we'll say divide by distance divided by time. So probably you can give this operation want to do any name, but I'm just giving it a name called speed, because if you did physics, it's a distance over time. It's used to calculate speed. So now mathematics also. So we run it, so you can see unsupported operand type for list, and so that means a list cannot carry out a mathematical operation on entirely. So how can we do that? How possible can we create a mathematical operation using two lists? So that gave birth to NumPy. And before that, for us to be able to use NumPy, first of all, we have to import the library of NumPy. And I've told us in previous classes that one of the advantage, one of the good things about Python is that Python has a lot of libraries, and those libraries helps you to do whatever you want to do. So the simple thing you have to do here is know what that library does and just call it. Once you call the library, first of all, how do you call the library? You call it by importing. Okay, so let's see, you call it by importing that library. So let's import numpy. So we import numpy. So we import numpy as np. Okay, so numpy, we importing numpy means we are calling the numpy libraries. Every function that is inside the numpy library, just like we are under the umbrella of numpy right now. So once we call it here and import it and we run it, means we are covered. Okay, so we say import numpy as np. This is the standard. This np is an alias. Okay, so just like a nickname. So maybe somebody, my name is Gabriel, and somebody just call me Gab for short. Okay, so instead of we writing where we're supposed to write numpy, we'll keep writing numpy. It's stressful and it takes a lot of time, and it will take a lot of CPU space. So it's better we just give it a nickname to represent the numpy. Okay, so I have to run this here. So successfully we ran it. Okay, so now what we do, we want to create an array. Okay, a numpy array, and we call numpy arrays, we call them nd arrays, n dimensional arrays. Okay, so let's see, let's create a, so let's say mp underscore, I'm creating a numpy array to see if we can actually carry out a mathematical operation using a numpy array. Okay, so so equals to, I'm giving it np distance. Okay, so in creating a numpy array, first of all, since we have imported our numpy as np, you can import it and write as whatever, you can write whatever name, but the standard is np. Okay, so whatever name you give it as the alias, you try to always use it here. So instead of writing numpy now here, we'll now write np. Okay, so we're maximizing our CPU space. Okay, so plus dot array. Okay, so the next thing, we use the array function because contains nd arrays. So we have this, so we got this. So now we can pass a list of numbers here. So let's say we're passing we can pass a list of number, but since we've already created a list here, so let me just call the variable name. If you started with us in our first class, variable names are helpful. Instead of going over creating things all over again, you can just utilize variable names. Okay, so we've created an array with the distance list. Okay, so we can also, sorry, so let's utilize this. Copy, so let's paste it here. So let's say let's call this np time is equals to So np dot. So whenever you're creating an array, so you first of all import a numpy. Now you're creating a numpy array, first of all import numpy as whatever, but the standard is np. So always include the alias that you gave it as. So this np dot. So the next thing that follows is array, because it's a numpy array. So this, so we can pass a list inside. Okay, but whenever you're passing a list, make sure the list, if I'm going to say that later, so let me just copy this is a list already we've created, and we can paste it here. So now if we run this, good, it didn't throw us an error, meaning that we've succeeded in creating an ND, so whichever one you call it. Why we call it an ND array is it means n dimensional arrays. It can exist in multiple dimensions. Okay, so now let's see if we can carry out mathematical operation on the entire arrays we've created. So let's say speed is equal to and let's copy this, paste. So let's copy this also, then we can paste it here. So if we run this, okay, didn't throw us an error, so that means we can write this. So this, you see, so you can see we're able to carry out a mathematical operation on the entire list, so using the numpy. So what we did here was it gave us 10 divided by 0.30, 15 divided by 0.47, like that to the end. So you can see that we can only do that with the help of numpy. Okay, so now we'll proceed to, all right, we go over to the classes and attributes of ND arrays. That's what we call numpy arrays. Okay, we'll call them ND arrays. So one of the attributes of ND arrays is endime. Okay, let's just endime. What does it mean? We use this to find the number of dimensions. Okay, the number of dimension of an array. Okay, arrays can exist in multiple dimensions, can exist in single dimension. So now the arrays we've created up there, or let's see if we can create a new array. Let's say mp city. So let's create an array. Talks about mp city. So probably I'm just giving it a name. Variable names can be anything. If you've been following us up, we can give a variable names anything, but there are rules that are guiding creation of variable names. Okay, so what I do here is I'm going to, since we're working with NumPy, so this should be mp.array. So the array is a function, so we can pass a list. Okay, so let's say since I'm talking about MPCT, you must not create it's not because I'm not creating a city because this is called city, but I just want my variable name to align with what I'm doing. So I just pass list of cities. Okay, so before that, I want to tell us that one thing with a numpy array that is different from a list is that numpy array can only contain homogeneous values, unlike list that can contain mixed values of mixed data types. Okay, so if you are using strings in array, use string. If you are using float, use float. If you are using integer, use integer. Okay, so let's see, let's talk about cities in Nigeria. So let's say Jos. Let's talk about, let's say, Enugu. Okay, let's say Lagos. Okay, let's say Abuja. Abuja. Okay, so forgot this. So let's just use this. Okay, so these are cities we've created. It's a NumPy array. So created and run it. So let's check the dimensions. Let's check the dimension. What dimension? So I told you the dimension means what dimension, what how many axes. Okay, so we can use, so let's call on the variable name containing that data. So we'll just say dot end. Okay, so if I run this, you can see it contains, it's a one-dimensional array. Okay, so we can still just call this here so that we can view it. Can always view it. So it's a paste. So you see it's a one-dimensional array. So what we mean one dimension means it's in just one axis, just a single line. So we can create a two-dimensional array. So let's say let's just call it MP. Okay, let me just utilize this, copy this. Can say this is MPCT. I'm creating another variable name, so I want to create another array. So MPCT with symbols. Okay, let me just say with symbols. So probably want to create an array of the cities with their symbols. So we'll say MP. Anytime you are creating an array, remember using the MP array, because the MP is what you use as the alias. So whatever you use as the alias, you always call it here. Okay, so say mp.array. Okay, so let's utilize this. Let's pass this list, copy, just paste it here. So probably creating two-dimensional arrays. So now this is a one dimension. So for you to get another dimension, you always have to include another square bracket, okay, at both end. Okay, so automatically this is a two-dimensional array. So what you do is outside this other one, you just paste another. So Jos can be JS, that's a symbol. Enugu can put AG. Lagos we can say lag as a symbol. Abuja we can just say ABJ. Okay, sorry. Okay, so you see now when you're creating an array that's multiple dimensional, you have to make sure that the different list contains the same number of elements. You can see here is 4, here is also 4. Okay, so as we proceed, we'll just run it. So let's call it, let's see what we've created. So paste it, we'll run it. So you see, so this is one dimension, two. So let's prove what dimension, how many dimension is that. So let's say n dim. If I run it, this is a two-dimensional array. Okay, so ND arrays or NumPy arrays can be multi-dimensional. We can have 3 dimensions, 4 dimensions. We can have as many as can be. So okay, so we have another attribute. So let's copy this header. Let's copy this header. Okay, so let's copy it. So we have another attribute called the shape attribute. So the shape attribute. So the shape attribute, what does the shape attribute do? Okay, it consists of a tuple of integers, okay, showing the size of the array in each dimensions. Okay, so the length of the shape, it brings out a tuple, shows the rank or the dimensions. Okay, so the result it will give us is a tuple that contains numbers inside, and those numbers are showing us the size and their dimensions. Okay, so let's see. Probably we've already created okay, we've created NPCT before. We created, it's up there, so you can see it is up there. So we've created it already, NPCT. So let's check the dimension that NPCT belongs to. Okay, so let me just call it again. Let me just call it. You can see. So we've checked the dimension. So let's check the shape of NPCT. So we'll just say dot shape. So you see, I told you it's a tuple. So if you remember, a tuple contains curved bracket. So it gives us the shape. So it contains 4 elements inside. So let's see. We created another array, a two-dimensional array called MPCT with symbols. So definitely we can come here and say this. You can see it. So let's check the shape. Okay, so let's check the shape just by using the shape attribute dot shape. You can see, so I told you it contains numbers in a tuple. So these 2 means 2 rows, this 4 means 4 columns, or you can say 2 axes or 2 dimension, and in each of the dimension we have 4 elements each. Okay, so whichever way you want to explain, you can see this is the first axis, this is the second axis or dimension. Okay, so now you can see what we have. Okay, let's proceed. Let's proceed. Okay, able to utilize that, so you can see more of that in so many cases. So let's deal with another attribute called the size attribute. So we have to copy this. Okay, we'll look at the size attribute. All right, so let's make this a header. Okay, good. So okay, let me change this to size. So size is another attribute of an ND array. Okay, so what does the size do? The size gives us the total number of elements in the array. Okay, so it is equal to, let's say, the product of element of the shape tuple. Okay, like here you see we have 2 comma 4. So what the size does is it gives us the product of the shape tuple, or you can say the total number of elements in the array. So we remember we had NPCT. Okay, so let's just run it and see. Okay, so we had NPCT. So let's copy it. Let's check the size. So I told you the size gives us the total number of the array, or the product of the shape tuple if they are multidimensional. Okay, so let's paste it here. Then let's use the size attribute. In checking it, just dot size. So you can see, you see just 4 elements, or 4 elements that is contained here. You can see. So now let's check for that one with let's check this NPCT with symbols. That's a 2-dimensional array. So let's just call it here so that we can be seeing it as we check it. So what will happen here is just to put a dot size, sorry. So dot size. So you can see it shows us that the total number of elements in this is 1, 2, 3, 4, 5, 6, 7, 8. So it gives us the total number of elements in the array, or you can say it gives us the it gives us the product of the shape tuple. So you can see NPCT with symbols, the shape is 2 comma 4. So 2 times 4, which is the product, it gives us 8. So you can see that's it aligns with our definition. Okay, so we have a lot of sizes. You can have 2 comma 3 comma 2, where you can say 2 rows, 3 columns. Then in each of them they contain two elements each. So let's proceed. We have the D type attribute. So these are the 4 major attributes. Let's look at the D type attribute. So I think that's the last but not the least. Based, let's see. So if I run this, so we've been working with just the MPCT and the MPCT with symbols arrays we created. Okay, so let's see for MPCT, MPCT. So you can see it. So I told you that if you have a multidimensional array, it can only contains elements of similar data types. So you cannot have a multidimensional array, then probably you'll be having the first dimension integer, the second dimension maybe another data type of string or float. It doesn't work like that. So they must contain the same or homogeneous data type. So now we have this. Then what we want to check here is the D type. So we want to check the data type they belong to. So probably somebody is new to it and wants to know, please, what data type is in this array? You can just help the person by turning okay. I can check. You can write a code to check. So you can just say D type. That will give you the data type. So now before we normally have str, which means string, but right now it's the trend has been updated to using u. And what does u mean? U means a string. Okay, so u means string, and it's telling us that all the elements in this place, no one has a string that is greater than 5 characters. Okay, so you see less than 5 characters. So if you count this is 3, this is 5, this is 5 characters, I think this 2 is 5 characters. So none of them is having anything greater than 5 characters, so it's less than 5 characters downward. So so that's that. So we can check other ones. Okay, so that's that for that. If it's an integer, okay, probably let's create let me just say score. Let me just create an NP array that contains integers so that we can balance the equation. So let's say this, let's say we have 1 comma 2 comma 3 comma 3 comma 4. So we can run this. So you can see score. So we can check the D type or the data type, whichever one. So you can see int 32 bit. Okay, so that means it contains integer and the size of the integers are 32 bits. Okay, so this is all for the creation of an array and the classes and attributes of ND array. So we'll be looking at the operations that can be done in the ND arrays. So hello, welcome to another segment of our NumPy library class. We're going to be talking about basic operations, and basic operations will mean mathematical operations, logical operations, and comparison operations on the NumPy array, which is also called the ND array. And now we'll be doing this with the mathematical operator, we'll do this with the logical operator, and we'll do this with the comparison operator. And before we start, NumPy, as we know, uses indices of the element in each array to actually carry out basic operations. And in this case, where we are looking at a data set of we're looking at a data set of 4 cyclists during 2 trials. Okay, now the vector addition of the array gives will give us the output. All right, let's look at it and let's look what we're talking about. Now let's say let's create a variable name called first trial. So this is the first trial. So first trial. Okay, let's say first trial cyclist. I think that will go. So first trial cyclist. So we have let's enter a list of numbers. So we'll say 10, we'll say comma, let's say 15, we'll say comma 17, we'll say comma 14. Okay, that's 14. Okay, that will come. We'll say second trial, cyclist. So we enter another list. I will say 12, comma 13, comma, these things are outside. Okay, we'll move them out. So let's say this. Okay, so let's continue. Let's say 21. Let's say I'm just giving a random number. Okay, so let's say 24. Now you see now that these list of numbers with variables holding them. Okay, so we've passed this list, so let me run this. Okay, but first before we start using our NumPy library, I've told us you always have to import NumPy. Okay, so it's always good to do it above, whichever way. So far, as far as it's still on the platform, it's still the same thing. So we'll say import NumPy as MP. Okay, so then okay, so run it. So successfully run. So we've already run this. Okay, so let's form an array with these things we've run here. So let me just call these mp. Okay, let me copy this. Let me copy. Let's see, undo. Let me copy this. Copy. So we'll paste it here. So let's create a variable. Let's create an end array. Okay, so we say mp, since we say let numpy. So if you're in the first class, you have your way around this. So what we do here now is just to paste the variable name inside. So this one of the good thing about variables. So they just hold a memory of what you actually always want at the long run. So let's say mp dot array this. So I just passed this in, so I run it. So we successfully created array. So what we'll do next is we actually carry out a mathematical operation on them. Okay, so let's say okay, let's say this. So let's just use one of the mathematical operators. Mathematical operators, we'll talk about mathematical operators. We'll talk about the addition, we'll talk about the subtraction, the multiplication, the division, and the exponential. Okay, so we'll run this. Okay, so we'll put plus. So remember our definition in our previous video. I always say that one of the reasons why NumPy library was integrated into Python is because of the limitations of list. Okay, so having said that, we'll just come here, we'll paste it. So what was this? So let's just get this again. Copy. Actually, copy is not a good practice, but I just have to do to avoid wastage of time. So this what we have here. So I can run it, right? So let's run it. Okay, so we see what it's giving us. So you can see now that what happened here was 10 plus 12, 15 plus 13, 17 plus 21, like that to the end. So you make sure that whenever you're carrying out a mathematical operation on two different lists or more, what you have to do is make sure the number of items in the one is the same with the other. Okay, so now you can actually carry out any mathematical operation on it, whether it be subtraction, multiplication, addition, or the rest. So that is that. So we move on. Let's move on to assessing array element. So let's write this here. Assessing array element. So let's, in this case, we call it indexing. Okay, so we'll just make this, just give this 2. Right, okay, so let's bring it down a bit. Okay, so let's start with okay, let's say now you can access an entire row of an array by referring its axis index. So automatically every element in an empty array is assigned an index number, now ranging from 0 to, depending on how many they are there. So first let's create a two-dimensional array. Let me say cyclist trial. Okay, let's just say this. Please permit me to go up and pick that again. Okay, let's go on and pick let's pick, I think let's pick this, copy. So I'm creating an array, so I say np dot array is always the function. Okay, so I'll just have to pass let's have, it's a 62 dimensional. So first, this is the first, so we'll pass this, so there's a comma. So making it, having two brackets here means it's a multi-dimensional. Okay, when it's just one list, it means it, so this is a list embedded already, a one-dimensional already embedded in another dimension, so that makes it a two-dimension. Okay, so we strive also to see how we can bring this here, from here, copy, and we paste it, so you can see. All right, so this, we can run this. So now running this means we've created a two-dimensional array. We can always view if what dimension it is, remember, by using the end dime. So just put it here, say dot end dime. So if I run this, you see showing me that it's a two-dimensional array. Okay, so now we can also do stuff around it. Let's say I want to get just this first axis here. So let's just run this so that you can see, or let me get this out so that you can see how it is. So when I'm explaining, so you can see here, this is the first axis, then this is the second axis. Now in Python we start counting from 0, or in programming language as a whole we start counting from 0. So automatically, if we're assigning index number to, maybe we have multiple lists in an array, automatically we start numbering the list. This list is the first list, this one is the second. So by the virtue of this one being the first, it means this one is 0. This list index number is 0. So in case we're having multiple lists, so we can actually point them out by their index number. So it's just like you come around a place, maybe an area in a street, and you see every house is assigned a number, and for you to actually get to a particular house, you have to know the number of the house. So these are numbers that are assigned, so we call them index. Okay, so now if I want to access this list that is up here, this first list, the only thing I have to do here is, we have a pointer like this square bracket close to a variable name that is holding a container that is holding some objects, is always used to access things inside that variable name. Okay, so this square bracket is like a pointer. So let's say if I write 0, what does it mean? It means that I want to get this first index number. So let's just see, we'll run it. So you can see, all right, so I can still get the second one, still the same thing. The second one automatically, if the first one is 0, the index of the second one will be 1. Okay, so like that. So now this is how we can access elements or list in an array. So this is the first step to accessing elements using indexing. Now, what if I want to go inside? What if I want to access a particular element in that list? Now, it's like you now going to a house, going to a street. You first of all, when you want to locate a friend's house, you first of all locate the street, then the street number of that house, the house number. Sorry to say, the house number. Now, when you get to the house, you cannot see that your friend until you go inside. So now, we want to go inside and pick 15. We want to display 15 out. Probably, I've told you, we start counting, and elements in a list has index number assigned to them automatically. So this is having an index number of 0, this one 2, this one 3, this one 4. So like that. So if I want to access that 15, what do? I'll first of all go and pick the list it is containing. So it sees it is containing the first list, and the first list is having an index number of 0 if there are multiple lists inside. So 0. So if you have a multi-dimensional array, you first of all pick the index number of the list that thing you want to pick is contained inside. So the next thing you do is you actually go ahead and get the index number of the particular element. Now this, if this is 0, and this will automatically be 1. So I come here, if I come here, I just put 1. Let's run this. So you see it's having index number of 15. So that's how you can do for all. Let's say probably we want to access 24 in the second array. So I do first. Now this first pointer tells you if it's a multi-dimensional array. It tells you first, the first pointer is always for the entire list. Okay, so which of the list? So the second list, which is having an index number of 1. Then you move out, you put another pointer. Okay, now we are going deeper inside. So since we need 24 and this 12 is having index number of 0, this is 1, this is 2, this is 3. Okay, so I just have to put 3 here. So if I run it, okay, you see 24 is out. So that is how we do this. So let's move ahead. Let's talk about accessing array elements using slicing. How can we access elements using slicing? Now, first of all, we use slicing method to access a range of values within an array. Now you are not accessing individual elements. Now you are accessing a range. You are packing out a range. It's like a slicer. We've talked about slicers when we started with data structure. So it's like you are getting a range. You sliced the bread before. Now when you slice the bread, means you are getting a range. Maybe the one you can consume or the one you want to give out. So let's say okay, on this node I have okay, let's write the header. So accessing. So I like commenting so that whoever comes to my code can always comprehend what I'm doing. So Okay, so this, let's say slicing. Okay, so like this, let's say this is 2, let's say run this. So okay, so got this. So now first of all, you've seen that the shape of the array. Okay, let's call it you can see, let's say dot shape. Let's see, you can see it's 2 4, so 2 rows 4 column. So probably I want to get okay, let's see, let's view the stuff first. Now maybe I want to get 15, 17, 13, 21 out, all of them at the same time, this range. What I have to do here is, first I have to call the variable name holding it. Then the next thing to do is, since it's slicers, now there's a rule that we have for slicer. Now we say the first number that we put is always inclusive, the second number is not inclusive. Okay, because it's like a range. Now let's say we there's something complex about this. What will happen is, in this bracket, first of all lay the index number for the number of list we want to output in the multi-dimensional array. So for instance, if okay, so always we have 2 segments just in this bracket instead of going outside the bracket. So what we'll do is, we say since we can say from the first list to the last list, you know this column sign means 2. So to the last list, which is having index number of 1, we can say comma. So we want to access, so this now has fetched us from year to year. Just like saying, we'll come to your house and say, from the first born to the last born, please all of you come out. Then when they come out, I then now pick a particular person. So I've selected this using this slicer. Okay, so I've taken the whole range of this. So if I come here and I say, after this comma, what goes next is the range of value you want to collect from the number of the multi list you choose. So I want to get 15, 17, I want to get 13, 21. So what I do is, since all of them, 15 in this one is 1, that's the index number. 13 here, 1 is the index number. So I have to put 1. So put a column again. Remember, mind you, this column now, this other segment in this bracket, there's a comma separating it, is to enter inside the different list. So I come here, since 17 here, the index number is 2, then I put if I put 2, 2 will not be this 17 will not be outputted. So I have to extend it, because I said the last index is not always inclusive. So if I run this, okay, you see what happens here is, now the second number is not always inclusive, so it didn't include this second array, because this second array is the index number is 1, so it only took this. So what I will do here is, the wise thing to do here is, I'll say from beginning to end. If I put no number at the beginning, put no number at the back of this column, it means from beginning to end. So if I run this, you see it takes the 2 array now. So that is that. So you can still take a proper study about it. Okay, so we see what we can do about let's talk about iteration. See, still accessing arrays. So these are ways to access array elements. So we can also access array elements using iteration. Okay, so to make this, so this, so now what we'll do here is we'll use the iteration method to go through each data element present in the data set. Okay, so it's like iterations. Okay, we have people in a single file, and I say iterate through them. That means inspect all of them, make sure you inspect them. Okay, so that's what iteration means. Okay, so let's say still coming back to the cycling stuff we created, then at the top. Okay, well, we created it. Let me copy everything here. So let me copy it so that we can avoid taking too much time. Okay, so I have this here. Okay, let's run this. So iteration. So we paste this here. We're still making do with the data. Okay, so if I want to iterate, okay, we've run it up before, so let's run it again. Let's run it again. So we want to actually take maybe do an iteration on this. So what do we do? What do we do? So what we do here is there's we've done a for loop before. So for loop is actually used to iterate. So let's say for let's say for I, you can say for X, you can say for anything. So far something is there standing as a variable. So for I, let's say for I in, or for iteration, or for item in cyclist trial, that is in this container. But make sure you always define the container you want to use. So the next thing to do is you have to put a column. So now, mind you, so once you put a column, you get a proper indentation. Okay, so the next thing you do is a print what? Print item. So you print, now this item here represents everything inside here. So print whatever you put here, that's what you print out. If you put I, if you put X, if you put your name, whatever, that's the same thing you print out. Okay, so it means for every item, means for every, this item represents for everything here in this container called cyclist trial. Print them all. Okay, so if I run it, you see, print the first one. Print, if we have, let's say we have another one here. Let's copy this, copy, let's put the command here, let's put the command here. So let's just modify some of them. Let's modify some of them. So let's run it. So you see, it will go through all of them. Okay, so then so to go through all of them, to run, make sure all of them are outputted. Okay, so that what iteration does. Okay, so that is that. You can always iterate through things like, let's say let's call this np slicer, np slicer. So let me make it, give it a variable, let me run it. Okay, let's say sorry, where we created this, let's come back here and rerun it so that I can. So here that with this slicer, probably I gave it np slicer to hold the slicing of this thing. So remember, so So now what happens is this NP slicer is now holding, oh sorry, so NP slicer is now holding this. So I can just say okay, for let's say for x in NP slicer, okay, so if I just put this, come here, say print. So if I say print I, you see, okay, sorry, print x. So let's say print x. So you see what we have. So that's that for our class. So see you. Alright, welcome back. It's Simeon Gabriel. Yeah, we're still going to continue our course on NumPy. Now, today we'll be talking about the universal function. So let's create, let's see, universal function. Universal function. Universal function. So now there are some universal function. Actually, NumPy provides a useful mathematical function called universal function, and these functions operate element wise on an array. So producing helps to produce another array as output. So we'll be looking at some of these functions, and one of it is the square root function. The square root function provides the square root of every element in the array. So we also have the cos function that gives you the cosine value for all elements in the array, and we have the exponential function which performs exponentiation on which performs exponentiation on each element. You also have the floor function. It returns the largest integer value or every element in the array. So we'll be looking at them one after the other. First of all, we'll say first, before you do this, you have to import NumPy always as NP. To always remember that. But if you've imported it already, there's no problem. So we go into it. We say np dot sqrt. This is the function for square root. Okay. So let me give it a variable name. Let me say np. You can give it whatever name you want. np sqrt. Now okay. So we have this. Then we can just pass a list of numbers. So let's say 2, 4, 9, 16. Okay, I think this one will go away. So if I run this, I just say np underscore sqrt. If I run it, you see it gives us the square root of every element there. We also have the pi function. Okay, we also have the cos function. Okay, so what we do is we say from NumPy import pi. So this pi is actually a module that helps us to make use of the cos function. So I have to run it. So let's say let's bring this down. So we say np dot cos. Okay, np dot cos. Okay, we have it here. So let's say we're looking for cos 0, and you know cos 0 is 1. So let's check. Okay, we got it. So let's go over, let's say sine np dot sine. So with the help of this that we imported in this module, we can be able to use the trigonometric function of any type. So let's use the sine function. Let's say sine, probably let's say sine pi. Pi, you know pi is 3.142, approximately 3.142. So divide by, let's say 2. So we'll run it, you see. So it is giving us, so we can do a lot with it. We can still say np dot cos, then just say we can still say let's use the pi. You know, we imported the pi module, so we can see. So now we'll go over the floor function. Now what does the floor function do? It returns the largest integer value of every element in the array. So what we'll do, so like, okay, let's say we have what it will do, it will actually round off every number to the nearest whole number. Okay, so that's what will happen. So let's see np dot floor, then we'll say this. So probably let's pass a list of numbers. Let's say 1.5. Let's use float numbers so that you can see that it will round them off to the nearest whole number. So we have let's say 3.3. then this is okay. So if I run this, you can see okay. So this is what floor function does for us. Now we can also apply another function that is almost similar to this, but this one it will round it up, called the ceiling function. So let's put that here. Ceiling, I think that's like this. Okay, probably I'm not getting the spelling well. So so that's that for this. Let's just look at one more thing, the exponential. Okay, so let me just pass a list of number. Let's say 0, 1, 5. So we'll run this. So alright, so now we're going to shape manipulation. How we can manipulate our shapes, the shape of our array. Now you can use certain functions to manipulate the shape of an array, and the shape of an array can be changed according to the requirements you use in the NumPy library function. So now we structure an array, and we see how we can manipulate them. Now we have so many methods for manipulation shapes, and these are the flatten, the split, the resize, the stack, and the reshape. So we'll be looking at all of these. Now first of all, let's take a look at let's create NumPy array. So let's say new cyclist. So I'm just call it new cyclist. Then let's say np dot array. You know, this is how to create our array, right? So let's pass this. Let's see. Since I want this to be a multi-dimensional array, so I pass 2. So this let's say 10, 15, 17, 16, 26. I think this is okay. Do the same thing here. Let's say 12, 11, 21, 24, 14. So let's make sure they are the same number of elements in both lists. Okay, so I think they are 5. So we can run this. It throws an error, so we'll just call it new cyclist. So if I run this, you see it's a multi-dimensional array. So we can flatten this. You see the first axis, the second axis. We can flatten this. Okay, how do we flatten that? So we use the function ravel. Okay, so let me just copy this the variable name, put it here. Then once you just say dot ravel, automatically you flatten it. Okay, let's see. So you can see we're flattening it. We've changed it from 2 axis multi-dimensional array to a single dimension. Okay, so we can do a lot. So let's see again. How can we change or reshape a data set to 3 rows and maybe 3 rows and 4 columns? Let's see. Okay, probably let's how many are these? Let me add more numbers to this. Let me add more numbers to this. Or let me copy this. Let me give it a name called data, so that let's paste it. So, but let me increase this to let me increase this to okay. So let's say I want it to be 6. Okay, it's more than. So this is 6. We want to add one here. Let's say 23. Okay, so we'll run this. So what I want to do here, I want to carry out the reshape. So I want to shape it to another size. So you know that once I put this, just this is the shape it takes. So I can reshape it to any size, but depending on the number we're having. Okay, so we'll take a perfect. You can always reshape it to the perfect square. Okay, so let's say data dot reshape. This function help you to reshape it to any metrics you want. So let's say since this number let's check let's first of all check the size. Then we can be able to 12. Okay, probably 12 has a perfect square. So we can say data dot reshape. So what do we reshape it to? Now you know perfect square of 12 is probably 3,4. Okay, so if I run it, okay, I think okay, I'm getting it wrong here. So let's run this. So you can see now that it aligns well to the perfect square of 12. It aligns well to the perfect square of 12. So you cannot, let's say, you cannot come and say something that is abstract. Maybe let's say 5,4. 5,4 is a perfect square of 20. So you cannot come and say, you see, to tell you the shape array size into shape. You cannot. So you can always take the perfect square of that value, the size of the array. So we can do can reshape it to 4. It's like you are remolding stuffs from one shape to another. So we can be playing around with it, but it's still on that jurisdiction. Okay, we can still say 4,3 is still the same thing, meaning 4 rows, 3 columns. You see, you can still change it to, I think another way that aligns to 12 is 6 and 2. Okay, 6 rows, 2 columns. You can say two rows, 6 columns. Anyone works, whichever one you want. Okay, so I think that is that for a shape. We can also do the resize. So let's say data dot, we can resize it. So resize again, we can resize from whatever level to another level. Okay, so we've done the reshape here. We can still say the resize. They're almost similar things. Okay, so let's say we want to resize it to 3,4. We can still do it. So I think that resize probably, let's see. Okay, let's okay, I think, don't worry, I think the resize will only work. So the only thing we have to do here, we have to just call it. So you can see it has been resized back, so you just call it. So I think that is that. Then we can also do a split. We can split the array into two. Okay, so let's say np dot now these splits are of two type. Okay, so you can split. So probably let's say we're having that and let's say that this data and dot, let's reshape it. Let's reshape it to 3,2, 3,4, sorry. So you see that we can actually split this. We can actually split this. So we split the array into, let's split the array into two. So I can say np dot h split dot h split. Okay, and let me just underscore trial. Just give it a variable name. Trial equals to how do we split this? How do we split this? So what we'll do? Okay, let's just, we can use the let's just say, okay, I think let's h split is a kind of horizontal split. It's a function that help us to actually carry out a split. Okay, so let's say new, okay, let's say data dot comma, okay, comma 2, since we are splitting into two. So the h split help us to split this into two. So let's run it and see. You can see it carries out, it splits this part down, splits this other part down. Okay, so that's how we can split an array into two. So we can also stack the arrays together. Okay, we can stack them together. Okay, let's see how we can do that. Stack them together. So let's say we're creating let me still copy this. Let's say I'm copying this, copy, and probably I'm wanting to use it. Let's say I want to give it a, let's say new underscore one. That's the variable name I'm giving to it. So what we're trying to do here, we're trying to stack the arrays together. Okay, so so let's say np.array. So I think we've created one. So let's create new underscore two. So let's go up. I want to copy this part. Copy. So is equals to np.array. So we can paste this here. So run this. Successfully run. So what we can do here is we can do the h stack. Okay, they use the h stack function to stack the arrays together. What the h stack means is horizontal stacking. You know, once a horizontal, it stacks it horizontally, and horizontal is like this. So what we'll do, so let's stack it horizontally, because we did a H split. What we did was we splitted it, horizontally. You can see this is horizontally. So we clear this, side, it's horizontal split. We'll clear this other side, so that's horizontal split. So here we're doing horizontal stacking. Okay, so let's stack it. So we'll say np dot h stack. So we'll use the function. Then what we'll just do is we'll just pass the both variable name holding it. So we want to stack it, so we'll do a new underscore 2. So why is it throwing us an error? Okay, I think there should be another bracket outside. So run this, so you can see the stacking has taken place. So why we have to put another bracket inside? Now this outside bracket is for the function bracket. Now this meaning why we have to put another bracket is because we're taking two parameters. We're taking two entries. So that's why we have to. The other bracket is for it. So now the next thing we have to do is we'll be looking at broadcasting. Okay, so how do we broadcast? So broadcasting is to carry out arithmetic operation between arrays of different shape, and in this method what NumPy helps us to do, it automatically broadcast the smaller array over the larger array. Okay, so now maybe you have let's say let's create two arrays. So let me just write this broadcasting. So let's do this broadcasting. So we say let's create two arrays of the same shape. So let's say array, let's call it array A is equals to np. Don't always forget you're creating an array. If not, to throw an error, remember the array function, then you can just pass your list inside if you've not defined it before. So we can do this. So let's say this. So let's say array underscore b dot array. So let's say 0.3 comma let's say 0.3 comma 0.3 comma 0.3. Okay, so what will happen here is we will actually, let's run this. So we'll actually multiply the arrays. Okay, so multiply arrays. So what we'll do here is we'll say array underscore a multiply by array underscore b. So if we run it, what will happen is these 2 multiply 0.3, 3 will multiply 0.3, 5 will multiply 0.3, 6 will multiply 0.3. So that's what it means. So I've told you. So you see our result we're getting here. So now let's create a variable with a scalar value. Now this is what we call broadcasting. Now you know broadcasting is actually you are releasing a message from one channel to so many channels. That's what we call broadcasting. Like the radio station, you see, just somebody will be at one point broadcasting to different persons at the same time. So that's what broadcasting is. So we want to see how we can use a single scalar. When we have a single value, we call it a scalar value. Okay, so let's see how we can actually broadcast using a scalar value. So let's say let's call it scalar. So scalar is equals to 3. Let's say it's equals to 0.3. So I run it, then throws an error. So probably I can say array. Okay, I'll come down and say array a underscore a times scalar. Okay, you know scalar is 0.3, array a is a list. Okay, so to broadcast, what happens is this 0.3 will multiply 2, give us 0.6. This 0.3 multiply. Welcome back to another tutorial where we'll be talking about the intrinsic creation of arrays. Now what do we mean by intrinsic creation of array? All we mean here is we can be able to generate arrays without necessarily manually creating it. Now NumPy library has this function that helps you to the zero function. The zeros function. So what does the zero function do? So let's say np dot zeros. So it will create zeros for us, probably. Okay, let's see. Okay, let's give it a shape. So I'll pass a shape argument. Let's say 3, probably 3 rows, 3 columns. Okay, sorry, we've not import. Let's import. Actually, whenever you open or refresh your pandas library, I mean your Jupyter notebook, just have to always rerun the library, sorry, the NumPy library. So wherever, even if you have written it before, you can just go there, run it. But let me just run it here. So okay, successful. So I think this can run now. Okay, it says interpret 3. Okay, let's enter the shape. Let's enter the shape tuple. Okay, so this means 3,3 we can modify it to whatever. 3,4 we can say 5,4. So whatever shape you want it to take. Okay, so let's move to the next. We can also create np.once. I know what is in your mind, you're already guessing it. So right, you got it there. So let's say 5,5 or 10,5, whatever. So it means the first number is always for the row, second number is for the column. So you can see, so we've created, that's how to do intrinsic creation of arrays. Now another thing we're going to talk about is the arange function. The arange function. So the arange function, let me just talk about this. Now what this function help us to do, it helps us to take an interval. Okay, it just give us interval of the range we want to output. Okay, so probably I can just say np dot arange. Okay, if I say let's say 12, what I mean here is, okay, it means from 0 to 11. So you can see 0 to 11. All right, but there are 12 digits. Okay, you can still say this. You can just say 20. If you say 20, what we mean is 0 to 19. The number itself is not always inclusive. Okay, so now we can also do some stuff around this, around the arange. Remember we did the reshape function, right? So before that, let's say we can still take a range of 4 comma whatever comma, let's say comma 16. So you see, so whatever range you want to take. So like I want to say earlier, we did the reshape function, and the reshape helps us to coin or maybe reshape array to whatever shape we want. Now the a range, let me first of all apply the a range function. Here I can apply the restriction on it, probably let's say the range of 12. Then I can say dot reshape. Okay, let's say shape 3,4. I like using 3,4, so you can see. All right, so you can possibly reshape it to the multiples of that number, that range. Okay, so there is another thing that we can still do with this a range. Now if possibly this a range, I can say from 0 to, okay, from 1 to let's say 17, or 1 to probably 20. Okay, then I said, okay, I can enter another argument here which says, let me say 2. What I mean is it will have an interval of 2 to approach to this point. So if I run this, oh sorry, I have to give it np dot. Okay, so from 1 skip 2, so we'll be skipping to 2. So that's what this one, the interval of 2. So all right, that's the spacing. Okay, so I think that is that for this.